Um, Looking at question 6.1 says that two friends, Kuda and Tabo, each want to invest 5,000 Rand for a period of 4 years. Kuda invests his money into an account that pays simple interest at 8.3% per annum. At the end of the 4 years, he will receive a bonus of exactly 4% of the accumulated amount. Tabo invests his money into an account that pays an interest rate of 8.1% per annum compounded monthly. So, whose investment will yield a better return at the end of 4 years? Justify your answer with appropriate calculations. So, this is it's pretty straightforward. Let me just first indicate the information for each. So we're having Kuda, and the information that we have is this. Kuda also invests 5,000 Rand at a simple interest, right? So at a simple interest rate of 8.3% per annum, right? So what we have is that the investment is equals to 5,000 Rand, and the interest rate is 8.3% per annum using simple interest. And there's another thing that we are told is that bonus is 4% of the accumulated amount. So if we represent this into our timeline, we will have T0 there and T4, which is the period of 4 years, and the investment happens here of 5,000. Right, and we know very well that the interest rate from T0 to T4 is equals to 8.3% per annum, right? So the accumulated that we're going to find here, there's a bonus of 4% of the accumulated. So to really calculate this, because the question says that we need to know which investment yields better return, right? So what we're gonna do is this. We are going to use, because this is a simple interest, so you will say A is equals to P into 1 plus I multiplied by N, right? We want the accumulated, so the present value is the 5,000 that was invested at T0, so it's 5,000 into 1 plus the interest rate of 8.3. So you will divide that 8.3 over 100, you will get 0.083, right? And then multiply by 4 years, right? So the answer that you're supposed to get is 6660, right? So this is the accumulated amount, right? But remember that there's a bonus of 4%. So what is 4% of this amount here? What you can do is you can say 4% of the amount is equals to 4% multiplied by the amount of 6660, right? So this amount here, you will add it with the original amount that you got to get the actual amount, because this is just the bonus, right? So the actual amount is equals to 6660 plus the interest of 4%, 6660. So the actual amount, so you're gonna punch in your calculator this entire value here of 6,660 plus 4% of 6,660, and you're supposed to get 6926.4. So this is the amount that Kuda is going to get towards his investment. So now let's try to look for the situation of Thabo, right? So we know that Thabo invests 5,002 at a period of 4 years, and if we check here, Thabo uses an interest rate of 8.1% compounded monthly. So for Thabo, let me just do this. So for Thabo, he also invests an amount of 5,000 rand at an interest rate of 8.1% compounded monthly for a period of 4 years, right? N is equals to 4 years. So we have his timeline looking like this. So this is T0, T4. The interest rates from here to here is 8.1% compounded monthly, and we know that the investment of 5,000 was made, and yeah, for a period of 4 years. So to calculate the amount of Thabo, so you're going to say A is equals to P into 1 plus I to the power of N. Because it's compounded, hence we're going to use compound formula. So it's going to be 5,000 into 1 plus the interest rate of 8.1%. You can convert that, so you can say 8.1% divided by 100 and get the proper number of 0.081. Then you divide by 12 because it's compounded monthly to the power of 12 times the 4 years. So the answer that you need to get is 6,905.7, right? So looking at these amounts, for Thabo, we're having an amount which is equals to 6,905.7, and then for Kuda we have an amount which is equals to 6,926.4. So definitely it's easy to tell which investment yields a better return here. We're gonna look at the one that has the higher amounts, right? This is 6,905, this is 6,926. So definitely Kuda yields better return. So Kuda's investment yields better return. Fine, done with this question. So now we're going to do 6.2. 6.2, which says that 9 years ago a bank granted Mandy a loan of 526,000. So this loan was to be repaid over a period of 20 years at an interest rate of 10% compounded monthly. So Mandy's monthly repayments commenced exactly 1 month after the granting of the loan, right? So 6.2.1, Mandy decides to make monthly payments of 6,000 instead of the required 5,066 rand 0.36, right? How many payments will she make to settle the loan? So this is pretty straightforward. I'm just going to write the information that we have here. So the amount of the loan is 525,000, and the amount that Mandy is going to pay is 6,000 monthly, and interest rate is 10%, right? Let me just check. Yes, it's 10% for a period of 20 years. So it's going to be 10% compounded monthly, and for a period of 20 years. So our period is 20 years, but the question wants us to identify the number of payments that are supposed to be made, right? So please ignore this portion here for now. This period of payment of this loan. of 20 years, right? Please ignore it for now. In this question, we just want to find the number of payments. Remember that I just want to remind you that N in annuities doesn't mean number of years, it means number of payments. Please note that when you're dealing with annuities, N stands for number of payments. When you're dealing with simple interest or compound interest formula rather, N stands for number of years, right, or period, right? So because we want to identify the number of payments, and we know this is a loan, so we're going to use the formula of the present value annuity, which is x into 1 minus into 1 plus I to the power of minus n divided by I, right? So the loan that is taken here is 525000 is equals to, so payments would be 6,000 rand every month, so it's going to be 1 minus into 1 plus the interest rate of 10%, so 0.1 divided by 12 because it's compounded monthly, minus n, and then we divide by 0.1 over 12, right? So I'm just going to calculate the value of n, which is the number of payments. We want to know how many payments will be made for this 6,000 rand. So we're just going to cross multiply here. We'll have 525000 multiplied by 0.1 over 12 is equals to 6,000 rand into 1 minus into 1 plus 0.1 over 12 to the power of minus n, right? And you divide by 6,000 both sides, and we'll have 525000 multiplied by 0.1 over 12 divided by 6,000 is equals to 1 minus into 1 plus 0.1. If you check, I'm not punching anything from the calculator as yet, because that would be premature punching of the calculator. You know, you'll run off and then your answers won't be accurate towards the end. So you need to just do as I do here, by just writing the entire thing, and you'll punch everything towards the end, right? So we're going to transpose the 1 to the other side. You have minus 1 is equals to minus into 1 plus 0.1 over 12 to the power of minus n, and then now you can start punching this into your calculator, this whole expression here. Just punch it in the calculator and tell me what you're finding. So you're gonna get minus 13 over 48. So let me write it properly. So it's minus 13 over 48 is equals to minus into 1 plus 0.1 over 12 to the power of negative n. So because it's negative, so the negative will go away. You will remain with your 13 over 48 is equals to 1 plus 0.1 over 12 to the power of minus n. So because we're looking for minus n, so we're looking for n rather, so we have minus n is equals to the log, the base is 1 plus 0.1 over 12 and 13 over 48. So now you're gonna punch this in your calculator. You're gonna punch this here and tell me what you find. So it's going to be negative n is equals to you should get a negative 157.40. so the negative goes away, n is equals to 157.40. so just round up, n is equals to 158. So this is the answer for this problem here. So these are the number of payments that Mandy is going to make for the loan. Right, so we are done for this question here. We are done with 6.2.1. now we go to 6.2.2. right? So here, after making monthly payments of 6,000 rand for 9 years, Mandy required money to fund her daughter's university fees. She approaches the bank for another loan. Instead, the bank advises Mandy that the extra amount repaid every month could be regarded as an investment, and that she should withdraw this full amount to fund her daughter's studies. Calculate the maximum amount that Mandy may withdraw from the loan. So remember, Mandy was supposed to pay an amount of 5,066 rand 0.36 for the loan of 525, right? But Mandy paid more than that, so Mandy paid 6,000 rand. So there's a remainder of amount for her from the loan that she can use to actually pay for these fees. So we are mostly interested in the difference between this 6,000 rand and this 5,000 rand, and then we're going to calculate how much money will she have left. So what this means is this: Mandy was required to pay monthly installments of 5,066.36, right? But she decided to pay 6,000 rand, right? So meaning that the difference of these two is actually the amount that she has left, you know, because she's supposed to pay this for the loan of 525, but she ended up paying this. So the difference between these two, 6,000 minus, okay, let me write this properly. So it's x equals to 6,000 minus 5,066.36. So this is the amount that she has left, even though it's not an amount. We just gonna calculate the amount, or the future value annuity. So the difference between these two is just going to give you 933.64, right? So we're gonna use this to calculate the future value annuity of Mandy's payment of the loan. But because we are looking for the future value annuity, we want to know in future if she was paying an extra 933.64, so how much will she have made in future, you see? So hence we're not using the present value here. We just want to know how much will she have made in future. So we're going to use the future value annuity is equals to 1 plus I to the power of n minus 1 divided by I. So in future, Mandy is going to make the following amount, but before we do that, we know x is equals to 933.64. The I is equals to 10% compounded monthly, right? Remember that this repayment is made for a period of 9 years, right? So we're just gonna write our 933.64 into 1 plus 10%, 0.1 divided by 12 to the power of 12 multiplied by the 9 years, minus 1 divided by 0.1 over 12. So the future value that this extra amount of 933.64 will be 162. Let me just write this properly. So the future value is going to be equals to 162,503.5, right? So this is the future value, the amount that will Mandy will have left, will have remaining, by the way, remaining once she has repaid the loan. So this amount, she can use it to pay for the fees of the student, right? So we are done for this question. Off to the next one. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.